Hi everyone, and welcome. Thank you for joining us today for our webinar on protecting data at rest with software full drive encryption. My name is Kelvin Casada in product marketing here at Cigent, and today we'll focus on what it actually takes from a technical and operational standpoint to protect sensitive and classified data at rest. Today's session is really about setting the foundation on what data at rest is, why it continues to be a high-risk area, and how software full drive encryption fits into protecting data in real world environments, while also meeting CSFC for data at rest compliance. So, to deep dive into the topic, I'm happy to introduce Conner Crisafulli, Director of Solution Engineering at Cigent. Conner is a former U.S. Air Force Special Tactics Combat Controller with an active security clearance. He works closely with federal teams on designing, validating, and deploying data at rest protection strategies across endpoints, servers, and mission systems. So, again, with that, Conner, over to you.
Awesome. Yeah, thank you so much, Kelvin. As Kelvin mentioned, we are going to be discussing different ways to secure data at rest. First, we're going to talk about what that really means, what that is, why that matters to you. We're going to talk about software full drive encryption specifically, and how that can protect data at rest rapidly, and secure environments faster than other traditional solutions. We'll also touch on all the compliance mandates that data at rest protection has out there, especially in the government world. There are three main bodies that say you must do this in order to be secure from a data at rest perspective. And then there is also some considerations beyond just the technology. A lot of software full drive encryption solutions are very similar. So there's some considerations from a company level that you want to look at as well. First and foremost, just who we are and where Kelvin and I come from. Cigent is founded and was founded by a leading expert in data recovery and actually worked with the NSA. Then we received a lot of In-Q-Tel funding in order to start Cigent. We hire and focus on people that have experience in the DoD, people that have experience in the intelligence community and DoW, in order to have that clearance, have that knowledge, and have that access to be able to apply these secure solutions to your environment. And again, we're aligned with that most advanced data recovery laboratory in the United States. Somebody that can break in all these solutions is able to advise on how to make solutions nobody can break into. And we work with a lot of customers and end users in the intelligence community, in these communities that we come from, in the DoD. We work with a lot of the FSIs as well. And one thing we notice, and one of the reasons we really wanted to put this webinar together, is we notice a lot of not misinformation, but maybe not a full understanding of how to properly secure data at rest, whether it is just using a self-encrypting drive, and we'll touch on why that's not adding any benefit, in fact, having a negative benefit if that's the only thing you're using for your security. And then, another misconception is that certain software full drive encryption solutions that are made maybe for more of a consumer-driven approach might be best suited for the Department of Defense, Department of War. And that's not the case. And we'll discuss that in detail here. With all that being said, just kind of getting into the what is data at rest. Data exists in three different states. So we have data at rest, data in use, and data in motion. Using a laptop as an example, data at rest is going to be when everything is shut down. There is no power to the device. It's not authenticated to. Essentially just sitting there in the corner. That's data at rest. Data in use is when you turn that device on, you are working locally on that machine, and you are authenticated to that machine as well. That's going to be your data in use. Data in motion or data in transit is going to be anything going from system A to system B. Think about sending an email, sending or transmitting any sort of data. That's data in motion. Today, for this session, we're going to be focusing specifically on data at rest and how full drive encryption can protect that state of data. So why is data at rest protection important? Now that we know what it is, why is it even something that we need to think about? Um, there's a lot more technological advancements today than in the past. Obviously, we're always increasing our capabilities. One point that is very handy and very good for us, but also leads to more information that is unsecure is the size of SSDs and the storage capabilities. So currently we can have all the way up to 8 terabytes being stored in a single laptop. You start talking about multiple drives on the same laptop, you're talking about terabytes of data and a large amount of that can be out on the edge, that can be lost, that can be stolen, that can just be inadvertently a drive gets removed and sent somewhere we don't want it to. This allows a lot of data to be collected at one time. And additionally, with these technological advancements, more AI capabilities are being pushed out to the edge. And these are algorithms that need to be secured. They can provide insight into what a specific job requirement is, and it can know and be trained for a specific job. And we don't want an adversary to have access to that if possible. So all of these different all of these different technological advancements just increase the threat vectors that are out there and that require a solution to protect data at rest. Additionally, there are quantum threat attacks that make us need to protect data against a harvest now, decrypt later methodology. What that essentially means is that the adversary could be collecting as much information as possible, and the second quantum computing is a viable way to decrypt encryption. They will have all access and unfettered access to everything they've collected. With a data at rest solution, you can ensure that everything has been erased from the drive. You can go into whatever management solution or consoles available and erase that entire computer if you are able to, and if you're able to detect that you might lose that device, therefore preventing that entire threat vector all at once. Additionally, with all this new technology, there have been different governing bodies like the NSA, like a NIAP common criteria across the globe, NIST, that's provided a lot of guidance on how you must secure data at rest protection and how you cannot just have a laptop with sensitive information on it without any sort of data at rest protection mechanisms in place. So now we've talked through what data at rest is and why it's important. Now we are going to kind of get into the meat and potatoes of recommended solutions. So a full drive encryption solution is what you need to secure data at rest. There are two different ways to implement a full drive encryption solution, one of which is hardware and the other of which is software. So on this slide, we're obviously going to be discussing the software version here. And there's a couple key components that kind of goes into a software full drive encryption solution that we'll get to on the next slide. But when you boot your device, the first thing that will happen is a software full drive encryption solution will ask you and expect you to respond with who you are. And then it will determine, based on what your admin has set up, if you should have access to that device and the information on it or not. If you have a successful authentication, you'll boot right into your operating system. And from there, everything happens in the background. You're encrypting and decrypting information in real time as you read and write to the drive. You open a document, it gets decrypted, you edit that document and save it, it gets re-encrypted. Everything is happening in the background without the user needing to interact with it. The only time you need to actually do something as the user is to authenticate yourself on initial boot up. And this has a lot of advantages because it's complete device protection from a software perspective. It's really easy to roll out across a fleet of devices, and there's minimal performance impact to the actual user. You're protecting the entire operating system, all files, application settings on there. And it's different than some sort of a file solution because when it comes to a file level, almost data in use solution, you are only encrypting individual folders, individual files. You have protections on, if your antivirus is turned off. This is a full system solution that at boot authenticates you and then has no impact throughout the use. You turn it off and the device is fully protected again. Some essential capabilities, like I mentioned, that go into selecting software full drive encryption is you need to make sure that when it comes to boot protection, when you're doing your initial authentication, you're actually being prompted to give information to prove you are who you say you are. If it's just authenticating based on the drive being in the correct device, this is not secure enough for the Department of Defense. As a special tactics operator, we would have different GTAC devices or Panasonic devices, like rugged computer devices on us. And if we lost these devices and somebody had access to them and we utilized a solution that just booted up as long as it was in the correct case, the enemy would have access to all the information on that drive. But if we had some sort of authentication mechanism that I only knew the username and password to, I had a specific YubiKey for, I had a specific smart card for, that would mitigate all of the issues that come without advanced boot protection. Additionally, we want to make sure that this software full drive encryption is made for the DoD, made for the intelligence community use cases, and it's not a consumer-driven product approach where there's not secure key handling, where the communication between the pre-boot layer and the operating system layer isn't secure. And we want to make sure that it's not just the company saying it's secure. We want to make sure that a third-party lab has taken this software full drive encryption, put it through all the tests of known vulnerabilities that are out there, ensured no keys are stored in memory, ensuring these transfer protocols are encrypted, and ensuring that it meets NSA and common criteria requirements to secure not only sensitive information, but top secret classified government information. So I mentioned on the previous slide that you want to make sure that the software after you use has been built for the environment it's going to be operating in. The most common, I would argue, software full drive encryption solution is BitLocker. It's a Microsoft native solution that can come free with a lot of different implementations of Microsoft. It can be managed quite easily, but the downside is that this has been developed for consumers. If it's not developed for the DoD or DOW, it will have a negative effect in your environment. This solution is not certified by the NSA, not certified by NIAP. It has not been tested by those third-party accredited labs for known and documented vulnerabilities. In fact, the opposite. You can do a quick Google search and see how to break into these devices or the most recent way somebody has broken into a BitLocker. You want to make sure, on the last slide, we talked about keys being stored and transferred, encrypted, and making sure that all of that is being done in accordance with the government regulations. This is not the case with a BitLocker or any consumer-grade data protection solution. And then additionally, I, as a consumer, am not going to want to adhere to FIPS and strict government standards. So unless you put on the right settings that it says to in the user guide, which is very easy to miss and is not always the case, you're not actually even being protected at all, according to the NSA, according to NIAP, according to NIST with their FIPS regulations. And you have to pick and choose between your authentication factors. There's no MFA even offered. I mentioned a lot about data at rest security regulations, just kind of getting into them a little bit, not to get too boring here, because a lot of regulations can be very long and tedious to read through. But first and foremost, a lot of people get a FIPS drive, and we were guilty of it in the military as well, just getting a self-encrypting drive that is certified for FIPS and thinking we were secure. That's just sadly not the case. What we were doing when we did that, when we procured a FIPS self-encrypting drive, is we locked the front door of our house and we left the key in the lock. It's locked, but anybody can walk up and turn the key, open the door, and get into the house. The self-encrypting drive is encrypted, but anybody can turn it on and decrypt it. There's no authentication, there's no challenge, there's no response. It's just letting anybody into the drive. You must take that one step further when it comes to self-encrypting drives and have an authentication mechanism to say, you are who you are, you should have access to that drive, you can decrypt it. And we'll get into hardware full drive encryption solutions a little bit more later. But another way to ensure, and quite frankly, a lot cheaper way to ensure that you're not only getting encryption, but also authentication, is through a full software-based solution. So a software full drive encryption solution encrypts and provides authentication to the data. And again, it's going to be cheaper than even the difference between a regular SSD and a FIPS certified SSD. On top of FIPS, there's the whole Commercial Solutions for Classified program, which is the NSA's gold standard. We've kind of referenced it a little bit previously in this session, but just to get into it a little bit more, a full classified solution should have a self-encrypting SSD certified to CSFC, paired with a certified pre-boot authentication platform that covers your hardware full drive encryption. And then you should also have an inner layer of software-based full drive encryption to capture another authentication and decrypt the drive from a software layer. This provides your defense in depth that if one layer is compromised, you still have another layer to go. I've been mentioning hardware FD a little bit on the last slide, so just kind of briefly touching on what that is it's an embedded storage device that is constantly encrypting and decrypting information that is controlled by another authentication software. This authentication software would be prior to any software full drive encryption booting and prior to any operating system booting. This is required by the NSA if you are procuring a self-encrypting drive. If you're procuring a self-encrypting drive again without PBA, it's essentially a waste of money because there is no control, no authentication, nothing that actually utilizes the encryption features you're paying for when you buy such an advanced device. And again, this is more expensive to implement than software FDE. You can argue it's slightly more secure, but it's a lot more tedious to switch out SSDs if the company you choose doesn't have a large variety of manufacturers like a Dell, like a GTAC, like these other vendors to come from the factory. We'll add that with the expense in the current market of hardware, software FDE is a great solution to rapidly deploy at least one step better than your current posture across an entire fleet of deployed devices. And then from there, any net new devices could be procured with the full data at rest protection suite that we've been discussing here. But software FDE is a cheap, fast, easy to manage way to get one step closer to full classified CSFC compliance. And then you have the utmost flexibility of what data you want to store on your device. It can be classified and you can treat it as unclassified. Kind of been discussing a lot about, more than the technology, you need to talk about who the company you're trusting for your data at rest protection is. You want to make sure that they are a full stack CSFC data at rest solution provider. You want to make sure they understand everything from the hardware to the pre-boot authentication software on the outer layer side. And you want to make sure they also understand everything on the inner layer so that you don't have to deal with multiple vendors, multiple different contacts to go to if you need support, different authentication mechanisms supported. You just want to go to one place and get everything from one vendor. Additionally, you want to make sure that vendor can kind of have everything provided from these different OEMs that you are already going to, and that you can do tech refreshes without having to go in and swap drives. You can go ahead and deploy software very quickly. And you want to make sure that they have expert support to be able to do custom development. Maybe you don't have a standard platform. Maybe it's a fighter aircraft. Maybe it's a heavy aircraft. Could be a drone. And you need a certain capability that's not in the standard software. Well, you should hope the company you're working with has US-based software development experience and that they also have the ability and willingness to assist you and your program. And then last but not least, you want to make sure that you're working with people who have been in the military, who have been in the intelligence community, who understand your mission flow and the annoyance of having 10 million passwords you have to remember to get into your laptop, your ATAC, all these different devices that you're utilizing. You have type 1 encryption on your radios. There's a lot out there. And somebody that understands how much a user needs to remember and can kind of plug and play into that flow where we could say, hey, a YubiKey would work really well here. And we can add that to our solution, or the solution already has it. You just want to make sure you can talk through that. And even a classified program, you want to make sure they have the clearance to come out to a SCIF, learn a little bit more if they have to, so that the solution can be tailored to you and to your program. I know there's a lot, but just to kind of sum up what we talked about today, data at rest, everything is powered off. That's what it is. Technological advancements are putting AI, large amounts of data, and not only just regular data, but large amounts of sensitive data out at the edge. That's increasing the risk that missions, programs, MAGCOMs are taking. Data at rest can be the answer, can be um, the reason that your ORM is still a risk low. It can be the reason that you do not have to worry as much about these devices being lost, missing, stolen, or captured. And these solutions, like a software full drive encryption, can be very cost efficient, can be very cost effective, can be rapidly deployed to all your endpoints to meet NIAP NSA guidelines, to have the flexibility to store classified, unclassified SAP information on these devices. It can also be the reason that you go and have a vendor who can do custom development and switch something about the product one way around for the other, so that you have the best solution for you and your program. But with that, I'm going to go ahead and pass it back off to Kelvin, kind of wrap up the session here.
Thanks, Connor. And thank you to everyone who joined today. If you'd like to go deeper or discuss how these concepts apply to your environment, we encourage you to request a demo or reach out directly. Connor's contact information is on the screen, as well as a QR code to schedule a demo. Again, thanks for your time, and we look forward to continuing the conversation. Thank you.